Now we know if there is a only DC signal how to write the waveforms and how to write the how to indicate them, how to represent them, that is capital V, capital suffix. If it is only AC signal, it is small voltage, small v and small suffix. If it is AC plus DC, we're going to represent that particular node by small v and capital out or capital in, capital node number. So let us now move on and try to find out the representation of very basic circuit components. We start with resistors. So you're all aware of the representation of resistor. So this is how it is represented. Its unit is ohms. It is represented by this symbol. Usually the resistance of a particular resistor. So it is not a resistance, we are talking about resistor, because in some circuits we may have to limit the current through a particular device. In such case we are going to use a resistor of certain value being represented by R value and suffix 1 2 3 or A B C D whatever. Now it is the resistor. Usually the resistor values are starting from ohms, kilo ohms, it is mega ohms, that's all. So we will not have the resistance in terms of milli ohms. There is nothing like micro ohm resistor, there is nothing like giga ohm resistors. Now these are usually not used to represent very small resistance or very large resistance. So we will never be using milli, micro and giga for representation of resistance. This ohm will start from few ohms, that is 1 ohm till 900 or 470 ohms or 860 ohms or so and so. Anything in the form of 1k, 10k, 100 kilo ohms, 150 kilo ohm, 220 kilo ohms, so they'll be represented in kilo ohms. So usually resistors are said as 22k, 33k or 47k or 470 ohms. So this is how the standard values of resistance will be available. So the resistance of all values are not available. So there are some standard values of resistance available. So if you want to use a particular value of resistance, you may have to go close to the standard value or make a combination of standard values of resistors to come close to your design value. Resistors, as it is said that the value varies from ohm, kilo ohm, mega ohm, hundreds of mega ohm, so on so. Surprisingly, these resistors are made out of different material, so they are always lumped in nature. Lumped, lumped in nature. That means the resistance value is concentrated in a particular area. So that's why, so since the resistance value is concentrated a particular area, as the value of the resistance changes, the dimension of the resistor will not change. So this is an important point to note. Even if it is few ohms of resistance, hundreds of ohms, whether it is kilo ohms of resistance or mega ohms of resistance, the size of the resistor remains almost the same. So this is a very important observation. The resistance value will not change the size of the resistor as long as its wattage, that is current carrying capacity of the resistor, remains same. Its size remains same. That is, we're going to have, so as we have ohms, kilo ohms, mega ohms of resistance, depending on their power dissipation capability, they will also be categorized as quarter watt resistor, this is 1 by 4 watt, half watt resistor, 1 watt resistor, so on so. Usually for all electronic circuit which are meant for low voltage, use quarter watt. The resistance wattage is usually 250 millivolts. So this is 250 milliwatts. Sorry, this is 250 milliwatts. For all power applications, we'll go for larger wattage, which is in terms of 1 watt or even more than that. So the resistors that are used in almost all the electronic circuit are of 250 milliwatts. So that is one important thing. And one more important characteristics of this resistor is that resistance value does not depend on the frequency of the signal. That is, the resistance value, whether it is 100 ohm, 200 ohm, 220 ohm, whatever the resistance value, R value is independent of the frequency of the signal. So why this frequency comes into picture? If the signal flowing through this resistor is an AC signal, the frequency varies. Even if the frequency varies, the resistance value will not change. That's what is, the resistance value is independent of frequency. When it comes to an AC signal or DC signal, you might have seen that there is an amplitude involved in that. This resistance value is again independent of amplitude of the signal. This is independent of amplitude of the signal. Whatever the amplitude of the signal, its value remains the same. Here a care should be taken that if the amplitude is too much, so that the current flowing through the resistor exceeds the power wattage of that particular resistor, it may harm the resistor. It may just make your resistor to burn. So as long as the current flowing through the resistor is within the allowable limit, the resistance will not change. If you increase the amplitude such that current exceeds, and if it blows off, that is, if the resistor burns out, then the circuit will become either open circuit or short circuit depending on the condition, condition what has happened to that resistor. So R value is independent of frequency and R value is independent of the amplitude as long as resistor is working fine, as long as it is safe. When it will be safe? If the current flowing through the resistor is less than the power that it can dissipate, the rated power it can dissipate.